Hi everyone. So now what I'm going to show you how to do is to format your tables properly in Microsoft Word. Now I know that, for example, Miss Hilbert likes to do all her pretty formatting in Excel. I like to use Excel for the data, for the numbers, and I then use Microsoft Word to make everything look pretty and have the right headings and so on. And since I've seen that some of you have been consistently forgetting things in your headings and messing up the decimals, I thought that I would do a video in which I would show you how to not mess that up. So the first thing that I'm going to do is my raw data table. And in my raw data table, what I need is my raw data, which is the data that I collected, nothing less and nothing more. So I don't want any averages, random errors, none of this should be in Microsoft Word, only my data itself. In this case, I have a bunch of coils. Now, the error here is not really applicable in the sense that if we assume we can count coils. However, these were coils in a Slinky, if I'm not mistaken, and therefore there must be some error, and therefore I need to think about this, and then I need to adjust the decimals accordingly, which is what I'm going to do in Microsoft Word. Then I had these times, and the error in my time is given by the last decimal in my time. So I see here that I have 11.5, but here I have 17.01. This tells me that Excel was too smart and removed 10 from my number that it shouldn't have been removed. I need to be very careful with these things because my decimals have to be consistent. So when I put this into Word, I need to fix all these little details, and there's just nothing I can do. I have to do that. You could alternatively just use the round function from Excel, but I don't think it's necessary in this case. So anyway, all I'm going to do is I'm going to copy this, and again I will press Control C, and I'll just go to Microsoft Word, Control V. Now of course I have a very basic table, but the beauty of this thing is that I just go to Design, and I just choose a design for my table that I like. Like I normally prefer something clean like this or like this. Okay, yeah. For example, this could work, right? Okay, so I'm going to choose this design, but again, you could choose any other of these designs. Please no fancy colors, just something functional. Even this would be okay. Actually, I'm just going to choose this. Okay, cool. So that's my raw data table. Now the first thing that I need to do, and this should have done it here, is to tell people that this is my raw data table. So how about I'm just going to write raw data table, and if you say that figure 1 or table 1, give it some kind of number, that's even better, so that you can later on reference it, like as seen in table 1, blah 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 blah. But remember to include your title so that people know that this is a raw data table. I know it sounds like common sense, but it's not. Now here in the number of coils, the student was counting the number of coils in a Slinky, and then they were running some actually, what were they doing? Actually, they were timing how long it took for the Slinky to compress itself. However, even though it looks like this should have no error, right? So you have 1, 2, 3, 4 coils. This is really not like that, because you're trying to grab the coils at a certain point, and it's possible that instead of getting exactly 1 coil, right, you're getting 1.2 coils if it's not exactly at the same place. Plus, the coils in a Slinky are, kind of spiral, so it's a little messy. So I will assume that there is an error to this, and that is more or less, let's say, 1/10 of a coil, just to be safe. So I'm going to here add my error. First I need to insert, and please don't be lazy, use this sign, which is the proper sign for error, plus minus 0.1 coils. Now what I see is that this doesn't properly fit very well, so I'm just going to change the font to something that works a little better. Actually, no, I'm just gonna leave it like this, and if you don't like it, that's too bad. Okay, so anyway, plus minus 0.1 coils. So I'm not done, because if the error here is 0.1 coils, the decimals have to be consistent, which means that the number of decimals here have to be consistent with the number of decimals here. Therefore, this is not 3, this is 3.0, this is 5.0, 7.0, 10.0, and so on. So all these guys have to have the same number of decimals as the error the device error in the number of coils. In this case, the device error is really not a device error, but it's determined kind of by hand. It's like, well, I was doing this by hand. I would say plus minus 0.1 seems like a fair assessment. And, you know, that's good enough. Now for the time, this is a digital device. We were using a timer. So our error is the last decimal. Now, this is just a mistake by Excel. This is our last decimal, which means that the error in the time is 0.01 seconds. So again, we go to the heading and we say insert symbol plus minus 0.01 seconds. And it's not enough to put it here. We take this, Control C, and we copy it after each one of these columns. Every column needs to have an error. Don't be lazy. Just write it for every column. It takes 2 seconds, and now we're done. Now what happens is, again, that these decimals are not consistent because we can't trust Excel with decimals. So you just need to manually change this. So this is 11.5, so add another 0. This is 19. We need 0.00, because remember, that's how precise our measure is. We're not saying that this is 19 plus minus 0.5. We're pretty sure this is 19 to 0.01 seconds of precision. So again, we add one more here, and so on and so on. And I would do this with every single value that I see is not, you know, according to standard. Cool. Well, surely you don't need to watch me do this, but you get the idea. The finished table needs to look something like this, and then you need to fix these other values. And that's the raw data table. Now, it's so easy to get the points for a proper raw data table. So there is really no excuse to mess this up. Get your device error with the units, and then make sure that the decimals are consistent. That's it. Now we're going to make the process data table. And again, if you make a process data table, it's a good idea. Can I actually, oh no, darn. Well, I don't know what I did, but I would really like, there you go, to be able to write it. So it's a good idea, as always, to write process data table so that people know that this is your process data table and not some other stuff, because sometimes I find that I have no idea which table that's meant to be, and I don't know how I did this, but I created a random column here. Anyway, process data table. So I go back to Excel, and in this case I don't need anything but the y, the dependent variable, and then whatever it is that I'm going to plot for my x. In this case, the average in time and the error. That's it. Nothing else. Sometimes you will use more than this, because for example, it could be that you need to linearize your graph, and then what you need to do is to plot 1 over sine of theta, or you need to plot 1 over t squared, in which case you will get the average, and then you will get the error, but then you will also get 1 over the average squared, or whatever, and then you will have to propagate that error and show the error there. So that's the only case in which your process data table will look bigger, simply because you need to take your independent variable and do things to it so that you can plot it and get a line. Otherwise, 3 things. So I'm just going to select them using Control and then left click. And I know that here I have it already pretty, but I'm just going to copy the ugly stuff so that you can see me modify it in real time. So Control V, and now it gets, okay, well, why did this do this? Well, I don't know how that happened, but what I'm going to do is just delete all these columns. Can I? Yeah, there you go. Okay, so again, coils. This is still not okay. I need these values. Now I could just redo this, but I can be smarter than this and just paste it here, and I can just erase this column. Okay. Also, I'm going to change the design of my table because this is ugly. So I'm going to use this one. Now, the average in time will depend on the random error. And the random error, remember, there's only one rule. It can only have one significant figure. So 0.047 is really 0.05. Everything else goes. 0.11 is really 0.1. Everything else goes. And so on. This is 0.1, Now you tell me which one this is. Say it out loud. Yes, it's 0.07. 0.06 is 0.02, and this is 0.1. Now for the step that people find tricky, because a lot of people are like, oh no, but this has different number of decimals. How can you do this? Well, that's how it works in physics. It doesn't work like that in biology, for example. They want the same number of decimals everywhere. In physics, that's what the IB wants. So sometimes you have different numbers of decimals, and that's just the way it goes. And also, this one has to have the same number of decimals as the random error. So then I need to look at this and be consistent. So 11.51 needs to finish after 2 decimals. So 51 and the 3 next go. This one, however, needs to finish after 1 decimal because this is 0.1. So it has to be 16.7. This one also 18.9. And so on and so on and so on. So this one's done. That's 96. This one, oh sorry, I left a 3 here for some reason. That should be 0.02. This is fine. And then this one is just 29.9. And now I have a process data table, which is what then later on gets plotted. And then you need to find the line of the speed, do the maximum and minimum slope lines, and so on. So again, raw data table. Don't forget your headings. Don't forget your units. Don't forget your device error. Your device error, not your random error. Don't forget that the decimals need to be consistent between here and here. Process data table. All we care about is what we're going to plot. So the average and the dependent variable. Also, we need the random error. If the device error is bigger than the random error, then we use the device error. Normally this will not happen, but sometimes it does happen, then just use the device error. And sometimes you will see that your random error is ridiculously small because for whatever reason, your 3 values just decided to be really close to each other. And when that happens, no problem. You say, well, I only had 5 values. One of these guys was really unlucky and the values were really close to each other. This is not realistic. I'm just going to use the bigger error. And then you just substitute it as long as you justify why you're doing this and the justification that you give makes sense, you're going to be okay. Now, if the justification that you give makes no sense, that's when things go south. Right, guys, so that's pretty much it. I hope this was helpful. If you have any questions, you know where to find me.